So for this problem, even though the square root of 16 and 25 would give you plus minus 4 over 5, we are only focused on the positive value of 4/5, because remembering in the example, we were only looking at quadrant 1, and that means in quadrant 1, both my sine and my cosine are going to be positive. So we're only focusing on the positive value of 4/5. Now the second part that it asked for was to find the tangent of theta. So now we know for sure two things that we've already solved for. We solved for sine of theta being 4/5, and then we were given in the original problem that cosine theta was 3/5. So thinking back to, again, that piece of the unit circle, and that cosine theta was 3/5 and then sine theta was 4/5. So that means, remember, if we're thinking about SOHCAHTOA, from theta, we have that y was our opposite, x was our adjacent, and then our hypotenuse was 1. So then from that theta, cosine is adjacent over hypotenuse. So if cosine theta was 3/5, that means our adjacent has to be 3/5, because 3/5 divided by 1 would give us 3/5. And then that also tells us that for sine, opposite over hypotenuse, if we got sine of theta was equal to 4/5, again, in order for this to come out to be 4/5, that means y would have to be 4/5, because 4/5 divided by 1 would give us 4/5. So remembering cosine theta is equal to x, and then sine of theta is equal to y. So if tangent of theta is equal to opposite over adjacent, well, we know tangent of theta then, again, looking back to what we've already figured out over here, opposite is our y, and then our y is just sine of theta. And then tangent, opposite over adjacent, our a is just our x value, right? Because it's our cosine theta is equal to x. So that means that we can rewrite this statement as tangent of theta is equal to sine theta over cosine theta. Because again, all I'm doing is I'm replacing my y with my sine of theta, because we've already shown that those two statements are equal to each other. Then I'm replacing x with cosine theta, because again, we've already shown that cosine theta is equal to x. And then now, having it in this form, it makes it a lot simpler to solve, because we can see that, well, we've already solved for sine of theta and cosine of theta, so we can just substitute those values back in to solve for tangent of theta. So I know sine of theta is equal to 4/5, and then I know cosine theta is equal to 3/5. So 4/5 divided by 3/5. And then I'm just going to go ahead and I'm going to rewrite this, showing instead of my fraction line as a division sign, just to make it a little easier to comprehend my next step. Because if I have 4/5 divided by 3/5, remember with division of fractions, we can change our operation to multiplication, and then we can take the reciprocal of our second fraction. So 3/5 would become 5/3. And we can go ahead and multiply those two values, and that gives us 20 over 15, which can simplify down to 4/3. So that means tangent of theta is equal to 4/3.